I'm A. Nirisha, Assistant Professor in the Department of CSIT working in MLR Institutions of Technology. So in this lecture, we are going to discuss about the recursion. In the last class, we have discussed about the recursion, its a syntax, and also about the two example programs, that is factorial and Fibonacci sequence. And in this lecture, we are going to discuss about the towers of Hanoi using recursion. So it's towers of Hanoi using recursion. The overview is what you mean by the recursion and also what is meant by the towers of Hanoi. And next, in the C programming language, the function can be made from main function, other functions, and from the same function itself. A recursion, a function called itself is called as a recursive function. So as we discussed in the last class, the function is calling itself. So to terminate that function, we are creating one base part inside the recursive function. So in the recursive function, we have some two parts. One is the base part and other one is the recursive part. Base part is used for terminating the recursive function and recursive part is used for the function calling itself. And whenever you call it. Towers of Hanoi. The Towers of Hanoi is a classical mathematical puzzle. The puzzle is often used to illustrate the concept of recursion in the computer science. The problem involving three poles and a set of disks of different sizes. And the objective of this puzzle is to move the entire stack of disk from one pole to the another pole. We need to follow some by following some rules. So the set of rules are nothing but only one disk we can be moved at a time. See, this is nothing but, this is a Towers of Hanoi problem. So this is the source and we're also calling it as A, and this is a destination. So we can also give the name as a C, and the next this is this pair. We are also calling it as auxiliary and we are giving the name to this pair as a B pole. The first pole is the source pole, second pole is the pair or B pole, and the third pole is the destination or C pole. As we discussed, the problem is involving three poles. The three poles are source, pair, and a destination. And a set of disks of different sizes. These are nothing but the disk. So here we have some 4 disks. We can use 4 disks, 3 disks, 5 disks, and some number of disks we can use. So this disk is of some different sizes, and you can see the arrangement of this disk. These are in the ascending order. So the first is a smaller one, and next is a bit larger, and next is a bit larger than the second one, and the last one is larger than all the disks. So thus all disks we need to move from source pole to the destination pole, or from A pole to the C pole in the same order. And here the following rules. The rules to be followed are only one disk should be moved at a time. We need to move only one disk at a time, either from A to B or B to C or to C to A, anywhere you can move. But only we can move only from one disk to from one pole to the another pole. And next, a larger disk cannot be placed on the top of the smaller disk. This is an important point to be noted. No larger disk to be placed on the smaller disk. And next, need to move all the disks in the same order. So this is of what order? In the same order, we need to move the disk from source to the destination. So Towers of Hanoi is a mathematical problem. Here we have some 3 poles and some number of different size disk. So we are moving that disk from A pole to the C pole, that is from source to the destination. So by following some set of rules, those are only one disk should be followed at a time, and a larger disk cannot be placed on the smaller disk, and all the disk should be moved in the same order. So this is one kind of the mathematical problem that we are going to solve in the C programming language by using recursion functions. So here, for suppose, consider these are some 3 poles in the first case. This is A, B, and C. So here we have only one number of disks. So if you have one number of disks, we can directly move from A to C. So for suppose, if we have some A, B, and C, if we have some 2 disks, so at that time, one disk we are moving from A to B. That is nothing but the smaller disk we are moving from A to B, which is on the top in the A. And next this, see, A to B, one disk, only one disk we can move. So one disk we are moving from A to B. And the next A to C, that is A will be empty, in the B will have the smaller one, and in the C will have the larger one. And next we are moving from B to C, that is A will be empty and B will be empty, and here C we have the larger one, and whatever the smaller one we have, that we are moving into the C. See, this what the order we have in the A disk, that we have moved from A to C in the same order, and we are following some rules that are only one disk we can move at a time. So what if we have some 3 number of disks? So we have seen the 1 number of disks, we are directly moving from source to the destination, and just now we have seen the 2, if we have 2 number of disks, with the use of B or with the use of spare pole, we are moving the 2 disks from source to the destination. And what we have some 3 disks, see here in A, one is larger one, and the next one is medium disk, and the last one, and the top of that is the smaller one, and in the B, this is B and this is the C. See, as we discussed, this is a source and this is a spare and this is a destination poles. So the thing is, we need to move this 3 number of disks from source to the destination. And the first move will be A to C. That is, in A we have 2 disks, that is larger 2 disks, and in the B we have no disk, and the C we are moving that smaller disk from A to C, the first move. And the next we are moving A to B. The A disk we are moving to B, that is nothing but the medium disk we are moving from A to B. Now in A we have the larger one, and in B we have the medium one, and in the C we have the smaller one. And now we are moving this we are moving this one disk, that is from C to B. So now in the A we have the larger disk, and in the B we have the medium disk, and the C disk, in the C what we have the small disk, that we are moving to the B, and in the C we have some empty. And now the next move will be is A to C. So in the A disk what we have, that is the larger disk, that we are moving from A to C. So now in the A we don't have any disk, and in the B we have 2 disks, that is a medium one and smaller one, and in the C we have the larger disk. And the next one is B to A. So in A we have the smaller one, and in the B we have the medium one, and in the C pole we have the larger one. And next B to C. In A we have smaller one, and in the B will be empty, and C we have larger one, and in the B what we have, that one we are moving to the C. So the C medium one. And the last step is A to C. So A will be empty, and B will be empty, and C will be the larger 2 disks, and also the A what we have. In A what we have, that one we are moving to the C, that is the smaller disk we are moving from A to C. So this is if you have n is equals to 3. And we can also try some n is equals to 4, 5, 6 and some number of disks. So here the point is, what we are doing is we are moving this 3 number of disks from A to the C, that is from source to the destination using spin. So some rules you need to follow when you are following this is n-1 disk we are moving from see here n-1 that is nothing but here we have 3 disks. So this 2 n-1 is nothing but the first 2 disks. We are moving from A to C. In this step you can observe this. We are moving from A to B using C. We are moving from source to spare using destination. And then next in the step you can observe the one disk we are moving from source to destination. And in the last step we can observe n-1 disk we are moving from spare to destination using source. So whatever the n value you are taking, so there's 3 steps you need to follow. So the first, initially accept the larger disk, the first 2 disks what we have in front of the larger, before the larger, there's 2 disks we are moving from source to spare using destination. And the next, whatever the large disk we have in the A, that we are moving from source to the destination. And next, whatever the disk that we have in the spare, that is in the B, we are moving from spare to destination using source. So by using this 3, so whatever the n value you are having, so if it is n3, 4, 5, 6, 7 and so on, whatever the n value you are having, so the n-1 disk we are moving from source to spare, and 1 disk we are moving from source to destination, and n-1 disk whatever we have on the spare, that we are moving from spare to destination using source. So there's 3 things you need to remind while you are writing a logic for this Towers of HANA problem statement. So this is the program. So here we are taking the return data type as an void, and this is a function declaration. This is a function call, and this is a function definition as we know. And it is return data type is void, name of the function is towers, and here how many parameters we are passing? 4 parameters we are passing. One is integer and rest of the 3 parameters are character values. And inside the main function we are asking the n value. So the 3 poles are constant. We are not going to change, or we are not going to read those 3 poles. So source, spare and destination. So for the 3 poles we are taking this 3 characters, and this int is nothing but the n number of disks. So how many disks you want? So that number of disks you are reading by n value, you are reading by using this scanf statement. Then next you are calling this towers function, and to this tower function what you are passing? A num value, n value, and a, c and b. A is nothing but the source. So this n number of disks we are moving from source to destination using spare pole. So as we discussed, A is nothing but the source, C is the destination, and B is the spare. So we are calling this tower function. So it immediately comes to the function definition. So num value will be copied to this num, and A value will be copied to the source, and C value will be copied to the destination, and B value will be copied to the spare. So this is a base part. So here we have written if n is equals to 1. So if n is equals to 1, what we are telling? We are asking to move from one disk from source to the destination. And if n is not is equals to 1. So we have seen, just now we have seen about the examples. If we have only one disk, we are moving that one disk from the source to the destination. So the same thing we have written here. And inside this, if this condition is false and is not equals to 1, then we are coming to the else part, and next to see here. So we are calling this same function, towers function, with n-1 values, and thus n-1 value, we are n-1 disk we are passing from source to spare using destination, and the next one disk, see print of that one disk we are moving from source to the destination, and then next we are again calling this towers function with what? n-1 values from whatever we have in the spare, that we are moving from spare to destination using the source. So these 3 important points that we need to keep in mind. So here we have towers n-1 from source to spare using a destination, and towers one disk printed, one disk we are moving from source to destination, and the next towers remaining n-1 disk we are moving from whatever we have in the spare, that we are moving from spare to destination using source. So these are the three important points that you need to remind. So here what we are doing here, we are calling this towers function. So towers num value is equals to 3. If you are taking n is equals to n value, num value as in 3. So n number of disks. So and next, so A, C, B. This is nothing but A, C, B. A is passing to the source and C is passing to the destination and B is passing to the spare. So we are calling this 3 function. So these 3 we have in the else part. So we are calling this towers function. So if we call this towers function, we are checking with the base condition. N is equals to 1. So n here value, this is the n value. And n is not equals to 1, n is equals to 3. So if n is not equals to 1, so it will come to the else part. And in this else part, we have written this. That is, say towers n minus 1, that is 3 minus 1 is equals to 2. And see here, source, spare and destination. The source value is A and the spare value is B and the destination value is C. And next, by using this printf statement, we are moving one disk from source to destination. So source here is sources A to C. The next again towers n minus 1 disk, that is here the n is 3, so 3 minus 1 is 2. From spare is B and the destination is C and the next source here is E. So now we are calling the tower function with n value as 2, A as source, B as destination and C as spare. So and now this is n is equals to and this is source and this is destination and this is the spare. So you need to remember whatever the values that we are passing, that will be copied to the source, destination and spare. So because we have here in this function definition we have given the first parameter will be passed to the n value num value, the next is to the source, next is to the destination and next is to the spare. So that is the reason why when you are calling this function, the n value will be 2 and the 3 functions, this 3 in the else part what we have. So that thing I have written over here. So that's the same thing that I have written here. So again we are calling this tower function with n as 2. So check this, n is equals to 2. So again we are checking num is equals to 1. So we have num is equals to 2. So 2 is equals to 1 false. So again it will come to the else part. And in this else part again we are calling this function. So again this towers and see here n minus 1 source, spare and destination. N minus 1, that is 2 minus 1 is equals to 1. And here source, the source is A, the next spare is C and the next destination, what is the destination value that we have, that is B. And next we have a printf statement, we are moving one disk from source to destination. So that is source to destination is, so in the statement the source is A and the destination is B. We are moving directly from source to destination. And again we are calling this towers function. So towers function n minus 1, 2 minus 1 will be is equals to 1 and spare. So from this function the spare value is C and destination is B and source here, source we have is B. So we are calling this tower function 1 as n, A as source, C as destination and B as spare. And this is n, this is source, this is destination and this is spare. So now we have towers n num value is equals to 1. If n is equals to num is equals to 1, then what we are doing, we are directly moving from, say, you can find here, if n is equals to 1, we are moving one disk from source to the destination. So one disk is, n number of disk is one disk. So that one disk we are moving from source, here source is A and the destination is C. And we are returning back to the towers function. So again this statement will get executed. Again next it will return back to the function which it called it. And again it will come over to the next last line, that is towers. So now here n is equals to num is equals to 1. So if num is equals to 1, then we are moving from source to the destination. Here source is equals to C and the destination is equals to B. Next After completion of all these three, it will return back to the towers function. So after it return back to the towers function, it has some printf statement that is source to the destination. So here by using printf, we are asking to print from source to the destination. Here source is A and the destination is C. So one days we are moving from A to C. Again, it will return back to the function which it called. So again, next we have towers function. So towers again 2, B, C and E. So again here now num value is equals to 2. So if num is equals to 2, yes, this C. This condition is false. So these three statements will get executed. So again we are calling this towers function with n-1, that is 1. And next here what we have, source, spare and destination. So from this function, source is B, spare is E and destination is C. So again towers function, any num is equals to 1. If num is equals to 1, this is n, this is spare, this is destination and this is source, destination and spare. And now we are moving from source to destination. Source is B and destination is E. And the next statement is printf source to destination. Here source is B and destination is A. So B to C. And then next we have last one more statement. We are left with one more statement, that is towers. So towers of n-1, that is 2 minus 1 is equals to 1 and spare, destination and source. Here spare value is E, destination value is C and source value is B. So in this case, this is n, this is source, this is destination and this is spare. So if n is equals to 1, we are directly moving from source to destination. Here source is A and destination is equals to C. So you can check, the first move will be is equals to A to C, the second move will be equals to A to B and the next move will be equals to C to B, next move will be is equals to A to C, the next move will be is equals to B to A and next it will be B to C and next it will be A to C. So just now we have tried over here, the first is A to C, A to B, C to B. So A to C, A to B and C to B. And next statement is A to C. The one does that we are moving from source to the destination. The remaining leftover one does, larger does what we have, that we are moving from source to the destination. So here next is A to C. And next we have some moves like B to A, B to C and A to C. So you can see here B to A, B to C and A to C. So these are number of steps that we are moving from one pole to the another pole to reach our target. So the target is to move that n number of pole in the same order from source to the destination. So whatever we have solved here, whatever the moves we have solved in this slide, the same moves we have got by using this, writing this code. So this is nothing. So in this way we need to write the program for solving the towers of Hanoi problem using recursion. So initially we are calling this towers function with ACB, and the next we are writing here if n is equals to 1, they are moving from source to destination, else the towers n-1 is we are moving from source to spare to destination, and next is we are moving from source to destination, and next is n-1 is we are moving from spare to destination using a source. So you can also check in the test cases. The first move is A to C. So as we got here A to C. The next is A to B, C to B, A to B, C to B. Next is A to C. B to A, B to C, A to C. B to A, B to C and A to C. So the same results we have got in our test cases also. So if we are giving n is equals to 3. Thank you.